In 2023, India launched the National Quantum Mission and became one of the few countries in the world to have a dedicated program to harness the power of quantum technology. But India is far behind China and the US despite having a fairly strong research base in quantum science. What is quantum technology? It is a class of technology developed in the early 20th century that works by using the principles of quantum mechanics, the physics of subatomic particles including quantum entanglement and quantum superposition. Hence, it is based on the phenomena exhibited by microscopic particles like photons, electrons, atoms, etc., which are quite distinct from the way normal macroscopic objects behave. As behavior of these microscopic particles cannot be described by classical physics based on Newtonian mechanics, consequently, quantum mechanics came into picture. The principle behind quantum technology application in more reliable navigation and timing systems, more secure communication, more accurate healthcare imaging through quantum sensing, perform a measurement of a physical quantity, more powerful computing, quantum computer, etc. Progress in India. India is currently at the forefront of tapping the quantum revolution through massive investment in the field. The Union Budget 2021 proposed to spend 8,000 crore on the newly launched National Mission on Quantum Technologies and Application, Rupee 3660 crore for National Mission on Interdisciplinary Cyber Physical Systems. What is Indian government's National Quantum Mission? National Quantum Mission will be led by Department of Science and Technology for strengthening India's R&D in the quantum arena and focuses on 4 key domains: computing, communication, sensors and materials. It will target developing intermediate scale quantum computers with 52,000 physical qubits in 8 years in various platforms like superconducting and photonic technology. Other objectives of the mission: satellite-based secure quantum communication over a range of 2,000 km within India and with other countries, develop magnetometers with high sensitivity in atomic systems and atomic clocks for precision timing, communication and navigation. It will also support design and synthesis of quantum materials such as superconductor, novel semiconductor structures and topological materials for fabrication of quantum devices. 4 thematic hubs, T-hubs, will be set up into top academic and national research and development institute in the domains of quantum computing, communication, sensing and metrology. The hubs will focus on generation of new knowledge through basic and applied research as well as promote research and development. The mission will have wide-scale applications ranging from healthcare and diagnostics, defense, energy and data security. Analyzing the progress of quantum technology in India. India lagging behind other nations. A new report has found the countries like China and the US have a huge head start in quantum technologies over India. Not only have these nations invested significantly more funds to research, they have a large number of professionals in this field, have been publishing more scientific papers and have registered many more patents. India still remains in competition. Indian scientists are at the forefront of research into quantum communication and quantum sensing. Even in areas such as computing and materials, the gap is not such that it cannot be bridged. Outside the European Union, India had the largest number of graduate students in disciplines biochemistry, electronics, statistics, ICT, etc. aligned to quantum technologies. There were more than 82,000 such students enrolled, which is more than in China or the US, way ahead for India. In a decade or two, a quantum enabled transition can lay the groundwork for a new economy by surpassing the limitations of existing technology. This is why India wants to rapidly build its capabilities in these areas. Partnering in technology development would ensure early success, leading to swift economic progress and access to cutting-edge technologies for India. The National Quantum Mission needs to identify and promote young talent, helping to raise a separate cadre of quantum scientists. Conclusion: there is much ground to cover and the National Quantum Mission is only the first step, but the good thing is that India is not exactly starting from zero. Quantum technology harnesses the principle of quantum mechanics to describe the nature of fundamental particles at the scale of atoms and elementary particles. Unique behaviors and properties of subatomic particles such as superposition and entanglement are harnesses to develop quantum technology. It is one of the most researched areas by governments and various private players involved in the development of quantum technology. It can broadly be divided into various verticals such as quantum computing, quantum communication, quantum sensors, and quantum materials. Working of quantum technology. A new probabilistic paradigm of quantum mechanics led the way to a better understanding of some key properties of quantum particles such as superposition and entanglement, which underlines the spectrum technologies. Applications of quantum technology. Quantum technology has unfolded new frontiers with widespread application. The key domains where quantum technology is applied are described below. Quantum communication. Applying the properties of quantum physics provides better security and long-distance communication. Quantum communication provides two advantages for security. In conventional digital communication, messages are decrypted and encrypted using keys and transmitted in classical binary bits 0 or 1. Quantum key distribution instead uses encryption keys that are encoded and transmitted using qubits, thereby making them more difficult to break. Second, qubits are incredibly sensitive. Any attempt to disrupt them or even observe them will help to collapse. Quantum simulation. To understand large quantum system or solve complex problems, there is a need to run quantum simulations. If a quantum system is simulated using another quantum system, it is easier to control and study. A quantum simulator does not need to learn quantum mechanics as it already works by the same rules. Alzheimer's, Parkinson's, etc. diseases have one thing in common, that is misfolded protein molecules. Quantum simulation can help us understand protein folding as well as help cure these diseases. Quantum simulation are crucial for developing high temperature superconductor. Quantum computation. It uses quantum physics to solve problems at speeds not possible with classical computers. While conventional computers use bits, the basis of quantum computing is the qubit. Superposition allows a quantum computer to perform many operations simultaneously and millions of times faster than classical computers. Quantum sensing and metrology. Quantum sensing is an advanced sensor technology that analyzes the change in motion and electric and magnetic fields at the atomic level. It allows for extremely precise measurements. It has a wide range of applications including healthcare and medical research, earth observation, early detection of natural calamities, environmental monitoring, construction, energy navigation and defense. Quantum materials. They are used to create solar cells and energy efficient devices such as batteries and diagnostic devices in health industries such as sensors and imaging devices. Example, fluoroscanned quantum dots can be used for multicolor bioimaging and labeling specific cellular proteins. Limitations of quantum technology. Although the benefits of quantum technology are versatile and promising, there are still following obstacles. Output observance. These mean that the data collection may happen if output information is retrieved after a quantum computation process is completed. Recurrence. During the computation phase of a quantum calculation, the slightest disturbance in a quantum system, for example, photon or wave of EM radiation, causes the quantum computation to collapse. This is known as recurrence. Security threat and advisory. With quantum decryption capabilities can theoretically access encrypted information with ease, putting most current communication infrastructure at risk of exploitation. Error correction. It is critical in quantum computing where even a single error in calculation can cause the validity of the entire computation to collapse. Quantum gates. High-end computing applications face the limitation of high qubits and high quantum gates.